Hi, today we're going to talk about the distributive property. We've already talked about the distributive property at school several weeks ago. So one of the things I want you to think about is Halloween. So if we're not using candy today, we're using fruit. So Rhodes is holding a pear. You can hold on to it. My husband, Chad, is holding an orange. Okay, so it's like they are in the parentheses. Okay, so we've got orange plus pear. Okay, they're in the parentheses. Just imagine they are in the parentheses, okay? So let's say we have a 2 on the outside. So we have 2 times, an orange, plus a pear. I need to distribute the 2 to the orange and the pear. So I need to say 2 times the orange. Well, what's 2 times an orange? If I have 2 times 1 orange, that's going to give me another orange. So let's give, out of my basket, another orange that's hopefully not rotten. So we distributed the 2 to the orange. So Chad is holding 2. Rhodes has 1 pear. So now we're going to say 2 times a pear. So if I have 2 times 1 pear, that leaves me with 2 pears. I can rewrite this as 2 times an orange plus, not that, 2 times a pear. So my final answer would be 2 orange plus 2 pear. Not too bad. That is how we show the distributive property. 2 orange plus 2 pear. Now, if I wanted to work backwards, I could see what's in common with the orange and the pear. What do they both have in common? Well, yes, they're fruit. I'm sure you're thinking, well, duh. But I can look at how many there are. There are 2 oranges and 2 pears. So I could say, let's divide by 2. If I divide 2 by 2, that leaves me with 1. 2 by 2, that leaves me with 1. And I'm back to where I started, with 2 on the outside times orange plus a pear. Now, we can't combine the orange and the pear because I don't think they've made a hybrid orange pear yet, and I don't know that I'd want to try that. They are not the same. Remember, in order to combine variables, they have to have the same variable and the same exponent. These are not the same variable. Okay, so now that we talked about fruit, let's think about vegetables. We're going to move on to vegetables. No, just kidding. We're going to talk about variables. So with distributive property, a lot of times we see x plus y. And then we have a number on the outside. And just like the fruit, we have to distribute what's on the outside to what's on the inside. So this would be 3 times x plus 3 times y. The lighting got way better. That's what we needed. Light makes all the difference in the world. Then I can say 3 times x is 3x plus 3y. Now, a lot of times students will say, well, that means this is 6xy. Can this be your answer? Why or why not? Well, remember when we talked about the fruit, I said you have to have the same variable and the same exponent. Are these the same variables? No, they're not. This is like the pear, and this is like the orange, or the orange and the pear. We can't combine them. So 6xy is not going to work. This is as far as it goes. Okay, so now I have 4x plus 16y. I want to find what the distributive property would have looked like, because this is like the answer. So I need to work backwards. So if something was handing out Halloween candy and distributing it to each variable, what would that Halloween candy have been? Or if someone was handing out fruit to each one, what would that have been? What is common between the coefficients? Do you notice anything common about 4 and 16? Hopefully you said factors. So what factors would work with 4x and 16y? There are a couple. So I'm thinking you're probably saying, oh, I know, 2. Yes, 2 would work. So I could divide 4x divided by 2. So if I take 2 out, that leaves me with 2 on the outside and 2x on the inside. It's the plus, so that stays the same. So what if I divide 16 by 2? What would that be? You're right, 8. So that leaves me with 2 times 2x plus 8y. That would be how we do it backwards. Is there another way we could do this? Is there something else that could be similar between 4 and 16? Are you thinking 4? Because I am. So if I take 4 out, I divide by 4. Another possible way to solve this would be, x, or 1x, because 4 divided by 4 is 1. But when 1 is the coefficient, it's kind of invisible. Plus, and what was 16 divided by 4? 4. So that leaves us with 4y and 4 on the outside. And I could check these. I could say, okay, 2 times 2 is 4, and 2 times 8 is 16, which would give me what we started with. Same here, 4 times x is 4x, 4 times 4, that would give me 16y. And it all works out. The distributive property is just looking at patterns. We notice that when things are in the parentheses, we can distribute this number on the outside to whatever's on the inside. It's like this is the guy with the Halloween candy, and they keep distributing what they are to each of those terms within the parentheses. Now time to practice.